Quantum computing is an emerging technology that leverages principles from quantum mechanics to process information in fundamentally new ways. Unlike classical computers, which use bits as units of data, quantum computers use qubits, which can exist in multiple states simultaneously thanks to superposition and entanglement. This allows them to perform complex calculations at speeds unattainable by traditional systems. For example, Google's Sycamore processor demonstrated quantum supremacy by solving a problem in 200 seconds that would take the world's most powerful supercomputer 10,000 years to complete. The potential impact of quantum computing is vast, spanning fields from material science and drug discovery to financial modeling. However, one area where it could have profound implications is cybersecurity. With their ability to break many current encryption methods, quantum computers pose both a threat and an opportunity for the future of secure communication. As we dive deeper into this topic, let's explore how these powerful machines might reshape our digital security landscape. Traditional computing relies on bits that are either zeros or one, forming the backbone of our current digital world. But quantum computing operates in an entirely different paradigm. Quantum computers use qubits, which can be both 0 and 1 simultaneously thanks to a principle called superposition. This means they can process vast amounts of data exponentially faster than traditional systems. For example, while a classical computer might take millions of years to factorize large numbers, crucial for encryption, a quantum computer could do it in minutes. The D-Wave system, one of the leading quantum computers, has already demonstrated solving complex optimization problems up to 10,000 times faster than traditional methods. As we delve deeper into this fascinating technology, understanding its potential impacts on cybersecurity will be crucial. Next, let's explore how these advancements could reshape our approach to data protection and security measures. Encryption is like the digital lock that keeps your information safe from prying eyes. It transforms readable data into an unreadable format, ensuring only authorized parties can access it. For example, when you send an email or make an online transaction, encryption ensures that your sensitive information remains confidential. According to a report by Cybersecurity Ventures, cybercrime is expected to cost the world $10.5 trillion annually by 2025, highlighting the critical importance of robust encryption methods. In fact, many governments and large corporations rely on advanced encryption standards like AES 256 to protect their data. As we delve deeper into the future, quantum computing could potentially break today's encryption algorithms, making it crucial for cybersecurity experts to develop new strategies to stay ahead. Next, let's explore how quantum computers might change the game in terms of breaking these digital locks. Quantum computing represents a significant threat to our current encryption methods. Traditional encryption relies on complex mathematical problems that classical computers can't solve quickly enough to crack codes in a reasonable time frame. However, quantum computers operate using qubits, which allow them to process information exponentially faster than traditional bits. For instance, Shor's algorithm, a quantum algorithm, could theoretically break RSA encryption, widely used, for secure data transmission within minutes. A study by the National Institute of Standards and Technology, NIST, estimates that large-scale quantum computers could compromise current cryptographic systems as early as 2030. This means we need to start preparing now with new forms of encryption that can withstand quantum attacks. As we move forward, understanding these vulnerabilities will be crucial in safeguarding our digital world. Quantum computing poses a significant threat to current cryptographic systems because quantum computers can potentially break many of our existing encryption methods. However, researchers are already developing new types of cryptography that can resist attacks from these powerful machines. One example is lattice-based cryptography, which uses complex mathematical structures called lattices to secure information. Another approach is code-based cryptography, like the McAleese cryptosystem, which has remained unbroken for over 40 years and could be quantum resistant. These algorithms are being tested as part of NIST post-quantum cryptography standardization process. As we prepare for a future with quantum computers, these new cryptographic methods will play a crucial role in maintaining cybersecurity. Next, let's dive into how quantum computing might change the landscape of financial security and privacy. Governments around the world are increasingly recognizing the potential impacts of quantum computing on cybersecurity. In the United States, for instance, the National Quantum Initiative Act was signed into law in 2018, allocating over $1 billion to support research and development in quantum information science. This not only aims to advance technological capabilities, but also to address security concerns that arise with these advancements. Similarly, China has launched a national strategy for quantum technology, investing heavily in both the development and regulation of quantum computing. These efforts highlight the global race to harness the power of quantum technologies while mitigating risks. As we move forward, it's crucial to understand how these regulations will shape the future landscape of cybersecurity. Next, let's dive into some real-world applications where quantum computing is already making a significant impact. Quantum computing poses a significant threat to financial institutions by potentially breaking current encryption methods. For instance, banks use RSA encryption, which could be compromised by quantum computers capable of running Shor's algorithm, thus decrypting sensitive data in seconds. According to a report by McKinsey, the financial services sector stands to lose $2 trillion globally if cybersecurity measures are not upgraded. This risk is especially critical for transactions and client information security. For example, JP Morgan Chase has already invested in quantum computing research through partnerships with IBM to stay ahead of potential threats. As we look at the broader implications, it's clear that financial institutions must adapt their security protocols to withstand quantum attacks. Next, let's explore how governments are preparing for this quantum leap in cybersecurity. Quantum computing is advancing rapidly, and recent breakthroughs are pushing the boundaries of what's possible. For example, in 2019, Google claimed quantum supremacy when their Sycamore processor performed a calculation in just 200 seconds that would take the world's most powerful supercomputer thousands of years to complete. This milestone highlights the incredible potential of quantum computers. Additionally, companies like IBM and Honeywell are making significant strides with more stable qubits, which are crucial for reliable quantum computing operations. As we move forward, expect even more advancements in error correction techniques and scaling up the number of qubits. These improvements will not only make quantum computers more powerful, but also more practical for real-world applications. With these developments, the landscape of cybersecurity is set to transform dramatically. Next, let's explore how quantum computing could revolutionize encryption, methods, and data security protocols. As we look ahead into the quantum era, organizations need to start preparing now for the potential threats that quantum computing could pose. One key strategy is adopting post-quantum cryptography standards. For instance, NIST has been working on developing these new cryptographic algorithms with a goal of publishing final standards by 2024. This will help protect against attacks from future quantum computers. Another important measure is to implement quantum-resistant protocols. In current systems, IBM, for example, offers tools that can simulate the effects of quantum computing on existing security measures, allowing companies to identify and address vulnerabilities before they become a real threat. By taking these steps now, organizations can ensure their cybersecurity infrastructure remains robust against the powerful capabilities of quantum computers. As we move into the next scene, we'll explore how governments around the world are responding to this new technological challenge. The race for quantum supremacy is heating up as countries like China and the United States invest billions to be the first to harness the power of quantum computing. For instance, in 2019, Google claimed it achieved quantum supremacy with its Sycamore processor performing a calculation in just over 3 minutes that would take the world's fastest supercomputer around 10,000 years. This breakthrough has accelerated global competition as nations recognize the strategic advantage quantum computing could provide, especially in cybersecurity. With quantum computers potentially capable of breaking traditional encryption methods, securing sensitive data becomes an urgent priority. As this technological arms race continues, it's clear that whoever masters quantum technology first will hold a significant edge in both defense and intelligence operations. Next, let's explore how current encryption standards might be vulnerable to these new quantum threats. Quantum computing is not just about breaking encryption, it's also poised to revolutionize how we use artificial intelligence. Imagine if quantum computers could process and analyze massive datasets at unprecedented speeds. For example, Google's Sycamore processor achieved a quantum supremacy milestone in 2019 by performing a calculation in 200 seconds that would take the world's most powerful supercomputer thousands of years. When integrated with AI, this kind of computational power could lead to breakthroughs in predictive analytics and machine learning algorithms. Take cybersecurity, for instance. Integrating quantum computing with AI could dramatically enhance threat detection systems, enabling them to identify patterns and anomalies far more efficiently than current technologies allow. This integration isn't just theoretical. Research institutions like IBM are already exploring these intersections. As we delve deeper into this relationship between quantum computing and AI, the potential for transforming cybersecurity is immense. Next up, let's explore how quantum-resistant algorithms can protect our data in a post-quantum world. Quantum computing poses both risks and opportunities for securing sensitive healthcare data. With the ability to process information exponentially faster than classical computers, quantum systems could potentially break traditional encryption methods that protect patient records. For instance, a study by IBM showed that quantum computers with just over 500 qubits could crack RSA 2048 encryption, which is commonly used in medical databases today. This vulnerability could lead to massive data breaches, compromising the privacy and security of millions of patients. However, quantum computing also offers new cryptographic techniques like quantum key distribution, QKD, which can provide theoretically unbreakable encryption for healthcare communications. For example, China has already deployed QKD networks to secure government communications, demonstrating its potential in high-stakes environments. As we move forward, the balance between these risks and benefits will be crucial for maintaining robust cybersecurity in healthcare. Next, let's explore how quantum computing is shaping the future of financial security. Quantum computing poses a significant threat to the security of Internet of Things devices. With its ability to process complex calculations exponentially faster than traditional computers, quantum technology could potentially break many of the cryptographic systems that currently protect EOT devices. For example, IBM's 53-qubit quantum computer has already shown promise in outperforming classical computers on certain tasks. This means that encryption methods like RSA and ECC, widely used in securing EOT devices, might become vulnerable. A study by the Cloud Security Alliance found that nearly 70% of organizations are concerned about quantum threats to their data security. As more devices connect to the internet, ensuring they remain secure against quantum attacks becomes crucial. In our next segment, we'll explore how current cybersecurity measures can be adapted or replaced to withstand these emerging threats. Quantum computing is revolutionizing how governments secure their information. For instance, the U.S. Department of Energy has invested over $625 million in quantum research to bolster national security capabilities. Quantum computers can process complex algorithms much faster than classical systems, making them invaluable for encrypting sensitive data and detecting cyber threats with unprecedented speed and accuracy. The Chinese government is also leveraging quantum technology to establish secure communication channels using quantum key distribution, ensuring that intercepted messages remain unreadable without the proper decryption keys. This not only enhances their own security, but sets a precedent for other nations to follow. As more countries integrate quantum computing into their cybersecurity strategies, we can expect a significant shift in how governments protect critical infrastructure and sensitive communications. Next, let's explore how this technology is impacting the financial sector. As we look towards the future of cybersecurity in the quantum era, it's clear that education and training are going to be absolutely critical. According to a recent survey by IBM, over 70% of IT professionals believe that their organizations need to start preparing now for potential threats from quantum computing. This isn't just about techies learning new coding languages. It's about building a workforce capable of understanding the complex interplay between classical and quantum systems. For instance, universities like MIT and Stanford are already offering specialized courses in quantum information science. But we can't stop there. We need continuous training programs that keep up with the rapidly evolving landscape of quantum technologies. By investing in education now, organizations will be better equipped to defend against future threats. Next, let's explore how governments around the world are stepping up their game in this new era. Quantum computing poses significant privacy concerns because it can potentially decrypt current encryption methods that safeguard our data. For instance, RSA encryption, widely used to secure online transactions, could be broken by quantum computers in a fraction of the time it would take classical systems. According to IBM, a 2048-bit RSA key, which is commonly used today, might only stand up against a quantum attack for about 15 years from now. This means that sensitive information, like financial data or personal medical records, could be at risk if we don't adapt our security measures soon. The European Union has already started investing in post-quantum cryptography to ensure future-proof privacy standards. As we move forward, it's crucial to stay ahead of these technological advancements to protect our digital privacy effectively. Next, let's explore how industries are preparing for this quantum leap in computing power. Quantum computing could revolutionize cyber warfare by giving nations an unprecedented edge. For instance, quantum computers can break current encryption methods that secure our data and communications. A study from MIT shows that within the next decade, quantum computers might be powerful enough to decrypt most of today's commonly used cryptographic keys. This means sensitive government information, military strategies, and even personal data could become vulnerable to attacks. Imagine a scenario where a nation-state with access to quantum computing capabilities could intercept and decipher encrypted communications in real time, giving them an unparalleled advantage on the battlefield or in espionage. As we look ahead, it's clear that cybersecurity will need to adapt to these new threats. The next phase of our discussion will explore how post-quantum cryptography is being developed to counteract this looming challenge. As quantum computing advances, it's clear that existing cybersecurity measures will face unprecedented challenges. International law is already grappling with how to address these new threats. For instance, in 2019, the European Union launched its Quantum Flagship Initiative, investing euros 1 billion over 10 years to develop a quantum technology ecosystem. This effort underscores the need for international cooperation and regulation. Countries like China and the U.S. are also racing ahead with their own quantum initiatives, raising concerns about global security standards. The challenge is how to create laws that can keep pace with rapid technological advancements while ensuring cybersecurity remains robust. To navigate this, we might see more international treaties and agreements focused on quantum technologies. For example, the United Nations could play a key role in setting guidelines for quantum computing ethics and security. As these discussions unfold, it will be crucial to balance innovation with safeguarding global digital infrastructure. As we look towards a quantum future, it's crucial for both individuals and organizations to take proactive steps. One key action is transitioning to post-quantum cryptography standards. For instance, NIST has already identified several algorithms that are resistant to quantum attacks, and they're expected to be finalized by 2024. Companies like Google have also started experimenting with these new cryptographic methods. Individuals can protect themselves by staying informed about the latest security updates and ensuring their systems are up to date. Organizations should invest in training and education for their IT staff on quantum-resistant technologies. According to a report from Deloitte, over 70% of companies surveyed plan to start implementing post-quantum cryptography within the next 5 years. By taking these steps, we can better prepare ourselves for the challenges that lie ahead as quantum computing becomes more prevalent. Throughout this video, we've explored how quantum computing is poised to revolutionize cybersecurity. Quantum computers can process complex calculations exponentially faster than classical systems, which could potentially break many of today's encryption methods. For instance, Google's Sycamore processor demonstrated quantum supremacy by solving a problem in 200 seconds that would take the world's fastest supercomputer 10,000 years to complete. As we look ahead, the development of post-quantum cryptography is crucial for securing our digital future. Companies like IBM and Microsoft are already working on creating cryptographic algorithms resistant to quantum attacks. The National Institute of Standards and Technology, NIST, has been evaluating these new methods since 2016. Moving forward, it's clear that understanding and preparing for the impact of quantum computing will be essential in maintaining secure systems worldwide. As we continue this journey into the future, stay tuned for more updates on how technology is shaping our world.